Here you see a camel carrying bananas from oasis A to oasis B and eating one banana. Before the camel started at A, a pile of 3,000 bananas was there. The question is, what is the maximum number of bananas the camel can bring to B if the distance between A and B is 1,000 meters, the maximum load is 1,000 bananas, and the camel eats one banana per meter? The problem has been discussed by several authors. Some use the unit kilometer or mile instead of meter. 10 meters or 100 meters would be more realistic, but anyway, it is just a brain teaser, not a realistic problem. Obviously, the camel driver must drop some bananas along the way so that he can pick them up later. Otherwise, he could not bring any banana to oasis B. For simplicity, half bananas or any other fraction may be dropped. In order to pick up all bananas at A, the camel must return 2 times. That means the distance between A and the first drop point P1 must be covered 5 times. It makes sense to drop 2,000 bananas there because afterwards the camel will need only one return to P1. The distance between A and P1 then is 200 meters, as the camel eats 5 times 200 or 1,000 bananas. In detail, first the camel starts with 1,000 bananas at A, drops 600 bananas at P1, and starts with the remaining 200 bananas towards A again. This procedure is repeated once. The third time, all 800 bananas can be dropped, as there is no need to return to A. The sum is 2,000 bananas. Instead of dropping 800 bananas, the driver will probably load 200 bananas and drive the camel to the second drop point, P2. From here, he returns to P1 and picks up the 1,000 bananas he has left there. With one return to P1, the camel covers the distance of 333 1/3 meters between P1 and P2 3 times, so that 1,000 bananas are available in P2. The camel starts from here with these 1,000 bananas and arrives at oasis B with 533 bananas and 1/3. This is the maximum number if fractions are allowed to be dropped. Is there any need to show this? The answer is yes, because there are many ways to achieve this number. This diagram shows how many times a point on the x-axis is crossed. Between A and P1, any point is crossed 5 times, 3 times from left to right and 2 times from right to left. Between P1 and P2, the number of crossings is 3, and behind P2, the camel runs straight away towards B. The 3 rectangles have an evident interpretation. Their areas represent the consumption of bananas. In the next figure, a point Q is selected right in the middle between A and P1. It might be an additional drop point where the camel drops 2,500 bananas and then from there brings 2,000 bananas to P1. This means Q is redundant like any other additional drop point because the total area of the rectangles remains unchanged. Now let us shift P1 or P2. For example, we shift x2, that is the x value of P2, from 533 1/3 to 600. As you see, the camel eats more bananas and delivers only 400 at B. That is a lack of 133 and a third. The lack of bananas is illustrated in this figure. Now we shift P2 to the left side by 33 meters and a third. In this case, the camel eats less bananas, 2,400, instead of 2,466 and two-thirds. On the other hand, it cannot pick up all 1,100 bananas at P2. 100 bananas must be left there. In other words, the reduced consumption cannot compensate this waste. This situation is illustrated in the next figure. The decrease of consumption, brown color, is smaller than the waste, both colors. The difference is the lack, yellow color. Now the summary is, in order to bring the maximum of 533 bananas and a third to Oasis B, P1 and P2 must be used as depots. Further drop points are redundant. On the condition that only whole bananas are allowed to be dropped, 533 is the maximum. For that, you select X2 as 533. However, the camel must leave one banana there because it cannot pick up more than 1,000 bananas at once. It can also leave one banana at A or P1 before. A tricky solution is to select X2 as 533.5. Then the camel must stop chewing while first downloading and later uploading 333 bananas at P2. Note that no half banana is dropped. Perhaps you like a similar problem, which, however, is slightly more difficult. The camel has to deliver 1,000 bananas at Oasis B. What is the least number of bananas located at Oasis A? Only whole bananas may be dropped and delivered. If you want to find the solution yourself, please press the stop key and continue the video later. My solution is 7,678 bananas, as you can see in the diagram. Analyzing the problem, you should start from the destination backwards. The number of bananas on a drop point must be as close as possible to, but less than, a multiple of 1,000. Remember the first camel problem. Let us compare the solution with this one, which is a lower limit for the preceding problem. Perhaps the minimum number of bananas is 7,677 or less. If you find such a solution, you are a genius. Good luck. Here is still another way to achieve the minimum number of bananas at Oasis A. The camel has to stop chewing half a banana while downloading and uploading bananas and must spit out half a banana 2 times. I hope you enjoyed the camel and banana problems.